This video is about the capture, mark and recapture process. This is a method for calculating an estimate of population size. It's a relatively straightforward process. As the name suggests, an ecologist goes out and captures a number of individuals from a population. They are then marked, released back into the population, and at a later date the ecologist then goes out and recaptures a second sample. By looking at the number of individuals that have been collected in the first sample, the number of individuals collected in the second sample, and the number of individuals who are effectively recaptured second time round, the ecologist is able to then make an estimate of their population size. But there are a few assumptions that we will talk about, and the key underlying principle behind this process is that the proportion of the marked individuals that are recaptured in the second sample represent the proportion of marked individuals in the population as a whole. What this tells us then is that if we have a small number of recaptures, then the population size must be large. If we have a large number of recaptures, then the population is going to be relatively small in that particular area. Now, there's a little bit of maths involved. It's not overly complicated, but we'll go through a few examples. We use the Lincoln-Peterson Index to help us through this. So, step one, the ecologist goes out, captures a load of individuals and marks those individuals. Now, the method that is used for marking varies on the type of species that you are collecting. So to start with, you might have birds, they get marked with an ankle bracelet. Snails can be marked with waterproof paint on their shells. Butterflies might have labels taped to their wings, whereas large mammals might be fitted with collars. Fish fins can be notched, and amphibians can have non-toxic dyes injected under their skin. In step two, once the ecologist has captured the organisms and marked them, they are then released. And the key thing here is to make sure that they are released as quickly as possible and as close to the collection site as possible. Because what we want is for those organisms to have an opportunity to recover from the trauma of being collected, but then to also mix randomly with the whole population. What the ecologist then does is goes out at some later stage and completes a second sample where he tries to capture a number of other organisms. And what we do with that is that we then allow us to calculate the size of the population by knowing the number of individuals that were marked and released first time round, the number of individuals that were collected the second time round, and the number of individuals that were already marked in that first attempt. So here's our example. You're going to estimate the number of long-necked turtles in Joondalup Lake. On the first day, you go out and you capture 24 turtles. You mark them and you release them back into the lake. A week later, you go out and you collect 60 turtles, 15 of which are already marked. So the question is, what is the population size? So stop the video now and take a moment to have a go at this. Alternatively, carry on and look through the answer. So M, which represents the number of individuals marked in the first catch, must be 24. The number of individuals that were collected in the second sample is 60, and that is represented by the letter S. And the number of individuals recaptured in the second sample is 15, and we use the letter R for that one. So I'll just walk you through this process quickly. So we have our equation that says the number of individuals in the population is going to be M times S divided by R. So we input our data, 24 times 60 divided by 15. And that will give us an estimate of 96 turtles. So the key thing that you can see here is that by increasing the number of individuals that are recaptured in our second sample, that will actually cause a decrease in the number that we get at the end of this. So it's really, really important that when we go through this process, we are making sure we capture as many individuals as we can. There are a number of assumptions that we need to be aware of when we have a look at this process. The first one is that individuals with marks must have the same probability of survival as other members of the population. So it's important to choose a marking method that does not harm the animal. At the same time, if a predator uses our paint to locate that particular animal, then we are going to end up with a lower number of recaptures. And that's therefore going to cause us to have the opposite, where we end up with a higher number of for our estimate. Births and deaths do not occur in significant numbers between the time of release and the time of recapture. If marked individuals die and are replaced with new individuals, then we will no doubt recapture fewer individuals. And so our estimate will be too high. Immigration and emigration do not occur in significant numbers between the time of release and the time of recapture. If marked individuals leave the study area or new unmarked individuals come in to replace them, then we're going to get fewer recaptures, and that's going to lead to a change in the equilibrium, and we're going to end up with a different estimate than what we would like. Number 4 says that our marked individuals must be able to mix randomly with the population at large. If the marked individuals do not get an opportunity to move among the unmarked individuals, then when we recapture them near the place where we released them, then the recaptured individuals are going to be overrepresented in our second sample. This is going to drive down our population estimate. Marked animals are neither easier nor harder to capture a second time round. This is different to what we were talking about in number 1. In this stage, what we're saying is that if an animal is frightened by the marking process, so much so that it becomes very timid and hides a second time, then we're not going to be able to recapture it, and that means that recaptured individuals is going to be underrepresented in the sample. On the flip side of this, if an animal is rather tame and becomes easier to recapture, then that is also going to induce errors into our estimate. Marks do not come off the marked organisms. This poses a particular issue for us when we're dealing with invertebrates, which are able to molt and shed. Some mammals can wiggle out of their collars, and it is possible for certain things to happen so that the marks become obscured. Again, if this happens, recaptures are going to be undercounted, and our estimate of population size is going to be too high. And finally, we make the assumption that recapture rates are high enough to support an accurate estimate. Now, we know that this one, number 7, tends to be the biggest issue for ecologists. And so what we do is we tend to move into a situation where we do multiple recaptures. And that's what we're going to go through next. And so we've got the Schnabel Index, and the Schnabel Index will show us how it's possible to do the maths behind having multiple recaptures. And these provide a much better estimate for us. Okay, so it's a scary looking, complicated mathematical equation. Don't worry too much about it. We're going to go through this in example. But the key thing for us to remember here is that we're still looking at the number of individuals that were previously marked. We're still looking at the number of individuals that have been caught and the number of individuals that are marked in our subsequent catches. But what we are doing here is we're putting in the subscript I, which basically relates to each individual recapture process, each sample, if you like. So here's our example. We're going to carry on trying to collect these long-necked turtles so that we can figure out how many there are in Joondalup Lake. So we go out, and in our first attempt we capture 100 of those animals, we mark them, and then we release them back into the population. About a week later we go up there and we collect 95. 25 of them are already marked, 70 are unmarked. That represents our second sample. So we mark those 70 that were unmarked and we release them back into the population. We go up there on a third week and we capture 105. 80 of them are unmarked and 25 are already marked. That represents our third sample. So we place that data into a table. The thing for you to note is that at M1, okay, at time 1, okay, M1 represents 0. This happens because we are starting the sampling and there are no marked animals at this stage. The thing to remember, though, is that for each subsequent time period, M1 is simply the sum of all the previous values in the new marked column. Okay, so pause the video, take some time to read through that and make sure that you are okay with it. So here's our table of data. Here's the equation that we're going to use. How do we actually put that together so that we can start to calculate our values? So what we're going to do is we are going to go in and we're going to say, if I can get my pen to work, here we go, that the number of individuals is going to be M1, which in this case is 0, and we are going to multiply that by C1, and C1 is 110. And we are then going to add that to 110, which is M2. And we're multiplying that one by 95, which is C2. And we are going to do our last one, which is going to be 180. That's M3. And we are multiplying that by C3, which is 105. And all of that is going to be divided by R1, which is 0, plus R2, which is 25, plus R3, which is also 25. So if I go through sticking that into my calculator, N is going to be 29,350 divided by 50. Carry on with that into my calculator and I will get a population estimate of 587 individuals.